All right. We have a function f of x, integral 0 to x, 2t cubed minus 15t squared plus 36t dt. When is f of x concave down? Well, f of x is concave down if f double prime is negative, right? So first off, we need to find f prime so that we can find f double prime. F prime, since this is just the integral of a constant, or from a constant to x of a function, the derivative of that is just that function in terms of that upper limit. So that should be f prime. And then, oh, I forgot my x there at the end. And then all we have to do is take the derivative of that and see when it's negative. So double prime ought to be 6x squared minus 30x plus 36. It looks like we could take a 6 out of that, and then we've got x squared minus 5x plus 6. So I think that's x minus 2x minus 3 is how that'll factor. And then we'll just make a sign chart with 2 and 3 on it and see on which intervals it's negative. So less than 2, like 0, we get a positive, negative, negative, which is positive. Between 2 and 3, like 2.5, we get positive, positive, negative, which makes it negative. And greater than 3, we get positive, 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 which makes it positive. Looks like it is concave down. The second derivative is only negative on the interval from 2 to 3. Good or no?
Good.
All right. Off to a good start. Next questions were about the 2014 test. So start with 2014 question number 8. Hopefully. All right. Fun, my toolbar is still not there. I can't switch back to the pen. Great. Had this trouble a bunch during last period too. Every time I did the screen clipping, it takes me away from the pen, and then my toolbar is not there and I can't switch to the pen. And then I just go back and forth like this. And then I don't have the pen. Thank you, Claire, for that information. I'm not going to type right now because that's just so difficult. Maybe someday soon we'll get my pen back and I can do this problem. But not right now. Now is not the time that that's working, apparently. So we're going to use the substitution that u is equal to sine of 2x. So if u is sine of 2x, then du is 2 cosine 2x. And we've got the cosine 2x in there. We'll do cosine 2x dx. So we've got the cosine 2x dx in there. So we're going to have to multiply this by 2, which means we're going to put a 1/2 on the outside. And this will be sine to the 5th 2x times 2 cosine 2x dx. And then we'll substitute out the 2 cosine 2x dx as our du, and we should have 1/2 of the integral of u to the 5th du. And we have pi over 6 here. And sine of 2 times pi over 6, that's the sine of pi over 3, which is root 3 over 2. And then the sine of pi over 2 times 2, that's the sine of pi, which is 0. So we should have 1/2 the integral from root 3 over 2 to 0 of u to the 5th du, which looks like it should be this one. Everybody good there? Any questions on that one? We had a couple other, Kayla, I know you said yours were actually 2015, not 14, but I'll come back to yours in a second. Since I have the 2014 one open, I got a couple others from 2014 that we'll do first. So we're going to do number 14 from 2014. And we're going to hope. Yeah, I'm just going to put all these ones from 2014 that we're going to do. We're going to do 15, and we're going to do, I think it was 18. I know this is really fun, exciting for you all, listening to me talk about what we're going to do. But I'm going to put all three of these in now because it's going to take my pen away, and then it's going to take me 20 minutes to get the stupid pen back again. All right. Yeah, my pen's gone again. The toolbar disappeared while we were doing problems. Hey, it came back more quickly that time. Good news. All right. So let's do number 14 here. We have the velocity of a particle. The v of t is sine 2t. We're given its position at t equals 0. We want to find its position at t equals pi over 2. So the displacement from 0 to pi over 2 ought to be the integral from 0 to pi over 2 of sine of 2t dt. And then we have to add our initial condition that at t equals 0, at our lower limit, it was at a position of 4. So we should have 4 plus, and then the integral of sine 2t is negative 1/2 cosine 2t. And we'll just run like this. And we'll evaluate that from 0 to pi over 2. And so we have 4 plus, and then negative 1/2 of the cosine of pi. So our cosine of pi is negative 1. So we have negative 1/2 times negative 1 is 1/2. And then minus, cosine of 0 is 1, so 1 minus negative 1/2. So we have 4 plus 1, which should be 5. Does that make sense to everybody there, number 14? No questions on 14. All right, let's look at 15. We want to know, when is g of x cubed minus 6x squared increasing? Well, when its derivative is positive, right? So we will find the derivative y prime, and that's g of u, with u equals x cubed minus 6x squared. So that's a chain rule problem. So it should be g prime of u times the derivative of u, which is 3x squared minus 12x. And we want to know, when is this positive? Well, when is g prime of this positive? Well, if g is always increasing, that tells me that g prime is always greater than 0, no matter what. No matter what value I plug in, g prime is always greater than 0. So this right here is a positive. So we have a positive number times 3x times x minus 4. And we want to know, when is this greater than 0? So we make a sign chart with 0 and 4 on it. And something less than 0, like a negative, is going to give me a negative and a negative. So that's going to give me a positive. Something between 0 and 4, like 2, will give me a positive and a negative. And something greater than 4 will give me a positive and a positive. So it should be increasing for negative infinity to 0, for to infinity, when that derivative is positive. Any questions there? Everybody okay with that? All right. We have a student. Uh-oh. It's always bad when a student attempts to solve an equation. So, in which step, if any, does an error first appear? So let's just go through and solve it. We should do dy over y equals x dx if we separate the variables, right? Divide by the y, multiply by the dx, and then we need to integrate both sides. So step 1 looks good. Yes. Step 2 should be natural log absolute value y. That looks good. Should be x squared over 2 plus some constant. That looks good. All right. Perfect. Then we should exponentiate. So e to the natural log equals e to the x squared over 2 plus c. So we should have absolute value y equals e to the x squared over 2 plus c. That plus c should be up in the exponent, but they have the plus c not in the exponent. Looks like the error is in step 3. Any questions on that?
I know like when we do like initial value problems, we usually plug in like our initial condition like right in like step 2. So if we didn't do it like that, where would we plug it in? Like if we solved it first?
You just plug it in at the end. So like if you solved it all the way through like this, and yeah, and then you just plug it in right now. You'd say y equals 2 when x is 0. So 2 is equal to e to your constant, so your constant is equal to the natural log of 2. And then you just plug it in up there. So you'd have y is equal to e to the x squared over 2 plus ln 2. And you didn't put that as your final answer. Does that make sense or no?
That does. Thank you.
Yep. All right. I think that's everything that people asked for from 2014. So now we will do 2015. Starting with number 8. Maybe. Let's see if I can put this problem in here without the pen disappearing this time. Nope. All right, here's what we're going to do. We're just going to pop in more issues. So, shown above is a slope field. So we have y squared times 4 minus y squared. And y equals g of x is solution to this differential equation with the initial condition that, let's see, what the g of -2 is equal to -1. The limit as x approaches infinity of g of x is what we're looking for here. So if we're looking at the initial condition is -2, -1, that's somewhere down here, ish. And so we would see that as our function curves up like this, we should be, oh, that was really poorly done. We should be flattening out to where we're going towards a value of 0. This should be going straight down here. But as we go towards infinity, g of x, the solution curve, should be approaching this, what appears to be a horizontal asymptote here. We can't actually see the values there when y is 0, but we know that the value there is y equals 0. The slope is 0 when y equals 0 because we get 0 times 4, which is 0. So we're flattening out to that value of 0. Does that make sense to everybody?
Yes.
All right. Next one. We got f of x and c is a constant. We want to know what constant makes f continuous at 2. So I think we talked to you yesterday again about the definition of continuity, but we know that the limit as x approaches 2 of f of x needs to equal f of 2. And they both need to exist and they need to equal each other. So we need to find the limit as x approaches 2, which tells us we need to find the limit from the left and the limit from the right. So the limit from the left, as we approach 2, ought to be x squared sine of 2 pi. And we need that to equal the limit from the right, which ought to be 2 squared plus 2c minus 18. So we ought to end up getting, well, sine of 2 pi is 0, so we end up with 0 is equal to 2c minus 14, or c ought to be 7. Good or no? Great. All right. We have the velocity, which is v in meters per second of a certain wave, is 3 root h. H is the depth. We want to find the rate of change in meters per second per meter of the velocity of the wave. So we're looking for the rate of change of the velocity. So we need to take the derivative of v of h. So in order to take the derivative, let's see, we're doing this. What is the rate of change in meters per second per meter of the velocity with respect to the depth of the water? Yeah. Yep. So it should just be the derivative of 3 root h, which ought to be 3 over 2 root h. And if h is 2, then that ought to be 3 over 2 root 2. Good or no? All right. We have got the base of a solid, and it's the region bounded by the x-axis and the graph of y equals root 1 minus x squared, which we should know what that looks like. Right? Root 1 minus x squared is just a semicircle with a radius of 1. Right? If we square both sides of that, we end up with y squared equals 1 minus x squared, or x squared plus y squared equals 1. So it's just the upper half of the circle that has a radius of 1 that's centered at the origin. Cross sections perpendicular to the x-axis are squares. So they have an area of the height, square root of 1 minus x squared, times itself, or squared. So our area of each cross section ought to be 1 minus x squared. So all we need to do is integrate 1 minus x squared, our area, from -1 to 1. Gives us x minus x cubed over 3. From -1 to 1. 1 minus a third minus -1 plus a third gives us 2/3 plus another 2/3, which is 4/3. Good or no?
Good.
All right. We've got f is the function given by f of x equals kx over x squared plus 1. We got k as a constant. We want to know if f is decreasing, or what values of k make f strictly decreasing on the interval -1 to 1. So basically, we just want to know what values of k make the derivative negative. So we'll take our derivative. F prime ought to be the quotient rule, x squared plus 1 times the derivative of kx minus kx times the derivative of x squared plus 1 all over x squared plus 1 squared. And we want to know what makes this negative. Well, this is not going to have any bearing on whether it's negative because that's always positive. So really what we're looking at is this kx squared plus k minus 2kx squared. We want to know when is that less than 0 for x values between -1 and 1. So we just need to figure out when that's true. Probably the easiest way to do that is to factor, factor out k. We have k times x squared plus 1 minus 2x squared, or 1k times 1 minus x squared, or k times 1 minus x times 1 plus x. And so the values that will make this thing negative, if we're talking about just from -1 to 1, well, from -1 to 1, what can you tell me about all these things? If I plug in anything between -1 and 1, like half or something, we're going to end up with this is going to be a positive and this is going to be a positive. No matter what I plug in between -1 and 1, this is always positive. So in order for this to be decreasing, k would have to be a negative number. So anytime k is less than 0, that derivative will be less than 0 because the rest of the derivative is just positive. Does that make sense to everybody or no?
That makes sense.
Wonderful. All right, let's solve the differential equation. dy over y squared equals 5 dx if we separate. Common mistake here is to write this as natural log absolute value of y squared. That is not correct. Right, this is only, you can only do that logarithmic anti-differentiation if this is just a y. Otherwise, this is y to the -2. We integrate that to get -1 over y equals 5x plus our constant. And then we'll plug our constant or our values in. X is 0. Y is 3. So we get a constant of -1/3. We have -1 over y equals 5x minus 1/3. And probably the easiest thing to do here is get a common denominator there. Multiply by 3 over 3. So we can then flip it. So we have -y is equal to 3 over 15x minus 1. And if you multiply by a -1 to both sides, we can distribute that -1 through the denominator and get y equals 3 over +1 minus 15x. Good or no?
Good.
Wonderful. All right. We got a table with values of f and f prime. And we know that f is always decreasing. We want to find, we have f inverse is the inverse function of f. We want to find what is the value of f inverse prime of 2. So that tells us that f inverse has a 2 comma something. We need then to find f, which has something, sorry about that, something comma 2. And so that happens when x is 1. So f inverse of the derivative of f inverse at 2 should be prime, should be 1 over f prime of 1. And we've got f prime of 1 is -8. So should be -1/8. Good or no? That's the inverse rule. There is almost always one multiple choice question involving the inverse rule. All right, let's do another one. Did we not do the ladder yesterday? Maybe we did that in my other period. All right, go to ladder. I'm just going to draw my own picture. Let's see here. Ladder's 15 feet. Even though this is a related rate, I'm going to put that 15 feet on because the length of the ladder doesn't change. I'm going to call this x. I'm going to call this y. I'm going to call this theta. We want to know, how is theta changing? We want to know what is d theta dt. So we're looking for that. We are given, let's see, the ladder is sliding down the wall. So that's dy dt. It's sliding down, this distance is decreasing, so it's a negative value for dy dt, -2. We know that the x value we're interested in is when x is 9. If x is 9, just a little bit of basic Pythagorean theorem, that's a 3, 4, 5 right triangle, right? Just they're all multiplied by 3, so that's a 9, 12, 15 right triangle. So we know what y is. And if we want to figure out what d theta dt is, we need to write an equation to relate theta with y, with probably that 15, that'd be the easiest. So that would be the sine of theta is equal to y over 15. I take the derivative with respect to t of both sides of that. I get cosine theta d theta dt equals 115 dy dt. We have dy dt, so we've now got -2/15 over here. We don't have d theta dt because that's what we're looking for. And we don't have cosine theta, but we should be able to find cosine theta. Cosine should be adjacent over hypotenuse. Well, that would be 9 over 15. 15s will cancel each other out, and we end up with d theta dt equals -2 over 9. Choice A. Questions on that? Everybody okay with that? All right, one more here. We've got f prime, which is the derivative of f. We want to know the value of x at which the absolute minimum of f occurs. So an absolute minimum can only occur at an endpoint or at a critical value. This is the graph of f prime. F prime, to have a minimum, would have to go from negative to positive. Well, this is not going from negative to positive here, so my only options are at the endpoints. And so it's not going to be half, it's not going to be 1, it's not going to be 3 halves. If we're talking about the integral of f prime, then this is going to be adding in positive area, and this is going to be subtracting stuff. So this is clearly a lot more negative than this was positive. We're adding a bunch of negative, should be an absolute min there at 2. Good or no? All right, we got one more question here that just came up. 5B and C from the 2014 FRQ. All right. So let's start here. I'm just going to put A in there anyway, just in case we might need it. There's part B. And part C. All right, and we have no pen again. All right, we'll have a pen again. Good news. All right, we want to know at what time t greater than or equal to 0 is particle x farthest to the left. Okay, so let's see, we were not given an initial position, it wouldn't appear. Okay, so we just need to figure out when is it moving to the left. So we'll take the derivative of our position equation, find v of t, which will be 15t squared minus 18t. We can take a 3t out of that, leaving us with 5t minus 6. We end up with t equals 0 and t equals 6/5. So we don't need to do anything less than 0 because we're talking only t values greater than or equal to 0. Plug in something between 0 and 6/5, like 1, you get a positive and a negative. So it's negative. Plug in something more than 6/5, like million, you get positive. So we're only moving to the left from 0 to 6/5. So if we're moving to the left that entire time, it should be farthest left at t equals 6/5. And just for part A, we would have looked for what is v of 1 for that. And v of 1 is less than 0, so we would have said it's moving to the left. So that's part A. And part B, furthest left at t equals 6/5, because then it's always moving to the right after that. Then part C, we've got a second particle moves along the positive y-axis with this position. And then it says we've got the vertices of a right triangle are the positions of x and y with the origin, which is a right. Gives us a right triangle. We want to find the rate of change of the area of the triangle at t equals 1. So the area of the triangle ought to be 1/2 base times height. Well, the base ought to be x of t, and the height ought to be y of t. So the area ought to be 1/2 of 5t cubed minus 9t squared plus 7 times the height, which was 7t plus 3. And we want to know the rate of change of that area at t equals 1. So we'll just take the derivative. You can distribute it all out if you want, or you can just use the product rule. It doesn't really matter. I guess I'll just use the product rule since that's what I've got here. 5t cubed minus 9t squared plus 7 times 7. And then 1/2 should be attached to everything. And then we have 7t plus 3 times 15t squared minus 18t. And then you just plug in 1 and see what you get. So looks like if I plug in 1, I should get 1/2. Let's see, that's 5 minus 9 is -4, plus 7 is 3, times 7 is 21. Plus, and that's 10 times 15 minus 18, so that's -30. So we have 21 minus 30 is 9 or negative 9 over 2. So it's decreasing at negative 9 over 2 cubic units per whatever the time is. They didn't give us a time unit, so. Does that make sense? Any other questions?